All right, so let's talk about classifying outliers. So if I gave you a data set and put a data point out here and asked you, does this look like an outlier or an unusually large value? I'm pretty certain you would say yes. And if I put that data point right there, I'm pretty sure you would say no. So the question then is, where? Yes, no. What about here? No. What about here? At some point in time, you're going to say yes. So this is what John Tukey was studying back in early 1900s. So he kind of said, let's come up with a rule for this. So he was looking at the IQR, measure of spread, and he kind of said, well, if I take Q3 and add 1 IQR, that kind of puts a fence here. That's not enough. But if I add 2 IQRs, it kind of puts a fence up here, and that's too much. So he kind of decided that he thought 1.5 was the right number that kind of gave us kind of matched up, or the formulas matched up with our intuition about where outliers were located. So he defined the upper and lower fence to be Q3 plus 1.5 IQRs and Q1 minus 1.5 IQRs. So that'll put a fence on each side. And if, by definition, if a data point is above these fences, we would consider it an outlier, or below the lower fence. So if a data point is larger than the upper fence or lower than the lower fence, it is classified as an outlier. Okay, just a rule of thumb, but it's pretty widely accepted. Note, if a data point is on the fence, it is not considered an outlier. So if it's right on the fence, it would be not an outlier. Okay? Where's the beef? The amount of fat in different McDonald's beef sandwiches was recorded. The fat content of each is given below. Makes it sound like this is a census. We've got data on every single one of their beef sandwiches. Not that it matters. It would matter if I was asking you to calculate the standard deviation, because you're going to give me that second value rather than the first. But here, we're just asked about outliers. So does this data set have an outlier? Well, I'm going to pause the video and put it in the calculator so we can take a look at it and decide. All right, so I put the data in the calculator. I called it fat. I put it into a list and spreadsheet. I go Control Doc and open up a new data and statistics page. I can look at a dot plot of those values. So what do you think? Most of the values here in the middle. We got a couple down here on the bottom and one on here on the top. So do you think this 9 is an outlier? Yes or no? What about the 12? What about the 43? I'm kind of feeling this 43 is, and the 9 is kind of close. Not sure. I'm going to say no. All right, let's see if it is. So let's calculate the upper fence. By the way, this formula is not given to you, so you need to memorize it. Q3 plus 1.5 IQRs. I have my calculator. I got the data in. I could run the statistics, but you know it's pretty quick to just go boom, 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 boom. So the median is right there. And then the Q13 would be the median of this, which is here. So Q3 is 29, and Q1 is median of the bottom, boom, 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 21. So the IQR is the difference, 8. This is 29 plus 1.5 times 8. 1.5 times 8 is 12. 12 plus that is 41. So there's the upper fence. That means this point here is bigger than that upper fence. So 43 is an outlier. What about the lower fence? What about that 9 or that 12 maybe even? Q1 minus 1.5 IQRs. That's 21 minus 1.5 times 8. That's 21 minus 12, which is 9. So that one is right on the fence. So it's right on the cutoff, so technically not an outlier. Okay. The 5-number summary. The 5-number summary consists of the following measures from a data set. The minimum, the median, the maximum, Q1, and Q3. Yeah, and I don't know if you recall or not, but that's basically those cutoffs that cut off the 25%, that divide the data set into 25%. So it's min, max, Q1, Q3, median. So and that's why they're called quartiles, because it divides the number line so it takes 5 values to divide the number line into 4 sections. So let's list the 5-number summary of the McDonald's sandwiches. Fat content that would be, and we could use a calculator. We have it here. You can do it here, or we could use a calculator. So let's open up and review again how to do the one variable statistics. Menu, statistics, stat calculations, one variable statistics, and put in your fat. It's the last 5 numbers, or 5 of the last 6 numbers, I guess, in the distribution. So 9, 21, 26, 29, and 43. 9, 21, 26, 29, and 43. Okay. Note the 5-number summary breaks the data set into 25 chunks. Percent chunks, discuss. Well, we discussed it. Or we'll discuss it more as we look at this a little bit deeper. So some mathematicians, some statisticians, I'm sorry, I lost my train of thought and I stopped the video because I got distracted and I can't remember where I ended. So if I'm repeating myself, I'm sorry, but statisticians thought that this is a really nice summary of the data set. So could we make a plot that illustrates this summary? And they came up with a box plot. Actually, I paused the video to see who it was. I thought Fisher created it. It was kind of called the father of statistics, or Tukey, the guy that did the outliers. And I wanted to stop and look it up to see who it was, so I wasn't wrong. And I couldn't really figure it out quickly, so I don't know. I think it might have been a few people. So, sometimes called a box and whisker plot. This is a graph of the 5-number summary with outliers highlighted. So you've seen these before, likely. They kind of look like that, okay? So first of all, the central box is drawn from Q1 to Q3. So that box represents the middle 50% of the data. The whiskers, a line in the box marks the median, so this would be the median. Then the whiskers go out to the smallest and largest observations that aren't outliers. So if there's an outlier in the upper end, it's going to go to the next biggest value, and this one would go to the smallest because there's no outliers. Outliers are marked with a special symbol, such as an asterisk or a dot or a heart or whatever you want to mark it with. Lucky number 7. Construct the box plot of the fat content for McDonald's sandwiches. So let's just make another number line that goes from 9 to 43. 5, 10, 15, 20, 25, 30, 35, 40, 45. Label your axes, fat and grams. And then let's just put a point at each of these numbers. 9, 21, or was it 19 or 21? 21, 26, 29, 31, sorry, not 31, 43. So we're going to put a box between the 21 and the 29. That's the central box. Drop a line at the median. Extend your whiskers to the smallest value and largest value that are not outliers. Well, where'd our data go? Here. 9 was not an outlier, but 43 was. So we're going to go to the next biggest one, which is 31. So the bottom whisker goes to 9. The top goes to 31. 31 right there. And then we use a little symbol or an asterisk or something for the outlier. Okay. So this is a nice graph to quickly see where the center is. There's the median, what the spread is. You want the IQR, measure that distance. You want the range, measure that distance. You want to see skewness, take a look at the lengths of these bars. We'll talk about how to handle that outlier in a future problem, okay? So very nice, simple graph. And our calculators can do it, of course. So I already have my data in here. Let's open up a new graph, Control Doc, open up a new page, Data and Statistics. Let's put in our fat content for our burgers and make a box plot. I'm sorry, I'm going too fast. I'm assuming you know how to do this already. You maybe do. Dot plot, go to Menu, Plot Type, Box Plot. If you cursor over these, there's the minimum, Q1, median, Q3, 31, 43. In fact, this is kind of cool. So if you grab this 0.43 and you can, like I'm corrupted my data, changed my data set, and that's not good, but if I make this smaller, 42, 41.543, look right there, right between 41, right at 41, that whisker extends to that point because the calculator calculates that upper fence, and if the data point is below the upper fence, it makes the whisker to that, and if it's outside, it goes to the 31. So the calculator uses the same rule for that upper fence. In fact, some people on these graphs will put fences at 9 and 41. Kind of adds extra information to the graph. You can see where the outlier, the fences are. And sometimes they'll even put a little diamond or something to represent the mean of the distribution. These are options, but any graph that has the more information, the better sometimes, right? All right. Distance from school. Analyze the distance from school in miles, create box plots, histograms, and dot plots. Comment on the advantages and disadvantages of each. Which do you like better? I'm going to save this for the next video because I do want to discuss a couple things.